Hello viewers, welcome to iTech Combo. In this tutorial we are going to learn one of the most important algorithm of machine learning, that is support vector machine. So let's see. There are some data. Let's say this is one type of data and this is of another type of data which is plotted out there, and I want to find out a line which is separating these two types of data. So let's say these are the lines out there, but let's say A is the line and B is the line and C is the line. Now let's say a hyperplane instead of line. Okay, so you can see this line A and B and C. Obviously the line B out there, the hyperplane B, is separating these two groups of data in the best way. Now let's come to this example, line B, C, A. Okay, obviously these three lines are also separating these two groups of data, but if you check the margin out there, B is closer to this group of data and further to this group of data, and A is nearer to this group of data and it's the farthest to this group of data. And if you see C, then you can check that this is also has a maintaining a distance from this group of data and also maintaining a distance from this group of data, so it has a best margin out there. Okay, let's check this margin out there there has a equal distance with this margin. Okay, so in this way actually support vector machines finds a hyperplane which is separating the two groups of data in the best possible way. Now come to an example. Let's say I have this plot out there, and let's say it's data for fever. Let's plot actually. So let's say in this axis I have plotted x1, okay, one of the feature of fever, and in this axis I have plotted x2. This is another feature of fever. So let's make a vector of them. So x equal to I can say x1 comma x2. So this is I am representing this into a vector, okay, x, where x is, let's say, hot temperature x1 and x2 is for feeling weak. Okay, and this is the feature vector x out there. Let's mark this. Now what are their level? So if I say their level, again draw, if I say their level is y, okay, y is either a negative number or a positive number. Okay, let's say for this group of data y is -1, and for this group of data y is +1. Okay, so I want to classify this group of data into two. So let's say this is the hyperplane out there which classify these two group of data into two. Now how can I define this line? Okay, for defining this line I have to take help of this one. Okay, so there are two groups of data out there, you can see, and this is the hyperplane out there, and for finding the hyperplane we are defining w out there and b out there. So what is w? So w is another vector, so which is normal to this line. Okay, so it is at a 90 degree with this line, so this is the w vector out there. Now what is b? So let's draw something here. Let's draw, let's take a point in this line. Let's take this point out there, in this line. Now draw this vector. so I'm ready drawing. So this is the vector out there. Now this is the W vector out there at a 90 degree with this hyperplane. Now if I dot product this line, then I will be having a value equal to this length. Okay, now if I subtract with some value, then I will be having 0 out there, since it's producing a scalar quantity. Again, let's take a point here. Now again draw the vector out there and W vector out there. Now if you dot product out there, then again you will be having a length out there. Okay, so numerically this value is out there is 1. Okay, sorry, this value out there is the B. So if you dot product with W and X and subtract with B, any point in this hyperplane will produce 0. Similarly, in this line, let's say any point out there is X. Okay, if you dot product with the W and subtract with B, you will be having 1. Again, any point out there in this line, if you dot product with X and subtract with B, you will have minus 1. So any point outside this line you will be having a lesser number than minus 1, and any point out there you will be having a greater number than 1. So after optimization, some mathematical calculation, you will have that this margin out there, let's draw this margin out there. Okay, we will be having this value. Okay, 2 by magnitude of W. So I want a greater margin. So to get a greater margin, I will need to minimize this value. So this is one of the condition to have a minimum value of W. Again, this length out there is equal to B by magnitude of W and I want a maximum value of this length. Okay, so another condition to have a maximum value of B. So these are the two conditions of support vector machines. To implement support vector machine through scripts, it's of complex algorithms. We will go for a simple one in the next next tutorial. Catch you then. See you there. Thank you.